हाय गाइस, दिस इज़ धीरज कुर्रे और स्वागत है सभी का आपके अपने यूट्यूब चैनल पे। आज के इस वीडियो में हम करने वाले हैं क्लास 12 मैथ्स का चैप्टर नंबर 11 विच इज़ 3 डायमेंशनल ज्योमेट्री। तो आज के इस वीडियो में हम एनसीईआरटी को लाइन बाय लाइन पढ़ेंगे एंड ट्रस्ट में ये आपके लिए काफ़ी हेल्पफुल रहेगा, फ्रूटफुल रहेगा। और आप भी एक पेन या पेंसिल लेके अपनी बुक के साथ टिक करिए। लेट्स स्टार्ट। The moving power of mathematical invention is not reason but imagination. A. D. Morgan. 11.1 Introduction. In class 11th, we'll studying analytical geometry in 2 dimensions. The introduction to 3 dimensional geometry we can find to the Cartesian method only. In the previous chapter of this book, we have studied some basic concept of vectors. We will now use vector algebra to 3 dimensional geometry. The purpose of this approach to 3 dimensional geometry is that to makes the study simple and elegant. In this chapter, we shall study the direction cosines and direction ratios of a line joining 2 points and also discuss about the equation of lines and planes in space under different conditions. Angle between two lines, two planes, and a line in the plane, shortest distance between skew lines, and distance of a point from a plane. Most of the above results are obtained by in vector form. Nevertheless, we shall also translate these results in Cartesian form, which at times presents more clear geometric and analytical picture of the situation. 11.2 Direction cosines and direction ratios of line. From chapter 10, recall that if a directed line L passing through the origin makes angle A, alpha, beta, and gamma with respect with x, y, and z axis respectively, called direction angles. These cosine of these angles, namely cos alpha, cos beta, and cos gamma, are called direction cosines of the direction line L. If we reverse the direction of L, then the direction angles are replaced by their supplements, that is pi minus alpha, pi minus beta, and pi minus gamma. Thus, the signs of the direction cosines are reversed. Note that a given line in a space can be extended in two opposite directions, and so it had two sets of direction cosines. In order to have a unique set of direction cosines for a given line in space, we must take the given line as a directed line. These unique direction cosines are denoted by L, M, and N. Remark: if the given line in space does not pass through the origin, then in order to find its direction cosine, we draw a line through the origin and parallel to the given line. Now take one of the directed lines from the origin and find its direction cosine, as two parallel lines have same set of direction cosines. Any three numbers which are proportional to the direction cosines of a line are called direction ratios of the line. If L, M, N are direction cosines and A, B, C are direction ratios of a line, then A is equal to lambda L, L is equal to lambda L, B is equal to lambda M, and C is equal to lambda N for any non-zero lambda belongs to real number. Note: some authors are also call direction ratios as direction numbers. Let A, B, C be direction ratios of a line and L, M, and R be the direction cosines of the line. Then L by A and M by B is equal to N by C is equal to K. Say K being a constant. Therefore, L is equal to AK, M is equal to BK, N is equal to CK, but L square plus M square plus N square is equal to 1. Therefore, K square by taking common from A square plus B square plus C square is equal to 1, or K is equal to plus minus 1 by under root A square plus B square plus C square. Here from equation 1, the direction cosines of the line are L is equal to plus minus A under root A square plus B square plus C square, M is equal to plus minus B square under root A square plus B square plus C square, N is equal to plus minus C is equal to A square plus B square plus C square. Where depending on the desired sign of K, either a positive or a negative sign is to be taken for L, M and N. For any line, if A, B, C are direction cosines of a line, then K, KB, KC, K naught is equal to 0 is also a set of direction ratios. So any two sets of direction ratios of a line are also proportional. Also for any line, there are infinitely many sets of direction ratios. 11.2.1 Direction cosines of a line passing through 2 points. Since one and only one line passes through two given points, we can determine the direction cosines of a line passing through the given points p, x1, y1, z1 and x is equal to x, x2, y2, z2 as follows in figure 11.3a. Let L, M and B direction cosines of the line PQ and let it makes angle alpha, beta and gamma with x, y and z axis respectively. Draw perpendiculars from P and Q to xy plane to meet it. R and S. Draw a perpendicular from P to QS to meet a new at N. Now in right angle triangle P and Q, angle PQN is equal to gamma from figure 11.3b. Cos gamma is equal to NQ upon PQ is equal to Z2 minus Z1 upon PQ. Similarly, cos alpha is equal to x2 minus x1 upon pq and cos beta is equal to y2 minus y1 upon pq. Hence, the direction cosines of the line segment joining the points p, x1, y1, z1 and q, x2, y2, z2 are x2 minus x1 upon pq and y2 minus y1 upon pq, z2 upon z1 upon pq, where pq is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Note the direction ratios of the line segment joining p, x1, y1, z1 and q, x2, y2, z2 may be taken as x2 minus x1, y2 minus y1, z2 minus z1 or x1 minus x2, y1 minus y12, z1 minus z2. Example 1. If a line makes angle 90 degree, 60 degree and 30 degree with the positive direction of x, y and z axis respectively, find its direction cosines. Solution. Let the direction cosines of the lines be L, M, N. Then L is equal to cos 90 degree is equal to 0, M is equal to cos 60 degree is equal to half, N is equal to cos 30 degree is equal to under root 3 2. Example 2. If a line has a direction ratios 2, minus 1, minus 2, determine its direction cosines. Solution. The direction cosines are 2 under root 2 square plus minus 1 whole square plus minus 2 whole square, comma minus 1 under root 2 square plus 1 minus 1 whole square plus minus 2 whole square under root 2 square plus same as it is minus 1 whole square plus minus 2 whole square, or 2 by 3. On solving we get 2 by 3 minus 1 by 3 and minus 2 by 3. Example 3. Find the direction cosines of the line passing through the points minus 2, 4, minus 2, 4, minus 5 and 1, 2, 3. Solution. We know the direction cosines of the line passing through two points P, x1, y1, z1 and q, x2, y2, z1 are given by x2 minus x1 pq upon pq, y2 minus y1 upon pq, z2 minus z1 upon pq, where pq is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Here p is minus 2, 4, minus 5 and q is 1, 2, 3. So pq is equal to in bracket 1 minus in other bracket minus 2 whole square plus 2 minus 4 whole square plus 3 minus into minus 5 whole square is equal to under root 77. Thus the direction cosines of the line joining two points are 3 upon under root 77, minus 2 upon under root 77, 8, under root 77. Find the direction cosines of x, y and z axis. The x-axis makes angle 0 degree, 90 degree and 90 degree respectively with x, y and z axis. Therefore, the direction cosines of x-axis are cos 0 degree, cos 90 degree and cos 90 degree. That is 1, 0, 0. Similarly, direction cosines of y-axis are and z-axis are y-axis and z-axis are noted down. This question must be asked in MCQ question. 0, 1, 0 and 0, 0, 1 respectively. Example 5. So that the points A 2, 3, minus 4, B 1, minus 2, 3 and C 3, 8, minus 11 are collinear. Solution. Direction ratios of the line joining A and B are 1, 1 minus 2, 2 minus 3, 3 plus 4, that is minus 1 minus 5 minus 1 minus 5, 7. The direction ratios of the line joining B and C are 3 minus 1, 8 plus 2, minus 11 minus 3, that is 2, 10, minus 14. It is clear that direction ratios of AB and BC are proportional. Hence, AB is parallel to BC, but point B is common to both AB and BC. Therefore, AB, C are collinear points. Here is exercise 11.1. Here is exercise 11.1. I will upload a separate video for it. Don't worry. Just look at the questions. I know you can solve it. 11.3. Equation of a line in space. We have studied equation of lines in 2 dimensions in class 11th. We shall now study the vector and Cartesian equation of a line in a space. A line is uniquely determined if first it passes through at a given point and has given direction. Second, it passes through 2 given points. 11.3.1. Equation of line through a given point and parallel in a given. Let A be the position vector of the given point A with respect to the origin of rectangular coordinate system. Let L be the line which passes through the point A and is parallel to the given point B. Let R be the position vector of an arbitrary point P on the line figure 11.3. Then AP is parallel to the vector B, that is AP is equal to lambda B, where lambda is some real number. AP is equal to OP minus OA, that is conversal y for each value of the parameter lambda. This equation gives the position vector of a point P on the line. Hence, the vector equation of the line is given by R is equal to A plus lambda B. Look at the figure 11.3. Remark, if B vector is equal to AI cap plus BJ cap plus CK cap, then A, B, C are direction ratios of the line, and conversely, if A, B, C are direction ratios of a line, then B vector is equal to AI cap plus BJ cap plus CK cap will be parallel to the line. Here, B should not be confused with under root with modulus B. Derivation of Cartesian form from vector form. Get the coordinates of the given point A, B, x1, y1, z1 and the direction ratios of the line B, A, B, C. Consider the coordinates of any point P, B, x, y, z. Then R vector is equal to x I cap plus y z cap plus z k cap. And A vector is equal to x1 I cap plus y1 z cap plus z1 k cap. B vector is equal to A I cap plus B z cap plus C k cap. Substituting this values in equation 1, Substituting these values in 1 and equating coefficient of I, j and k, we get x is equal to x1 plus lambda a, y is equal to y1 plus lambda b, z is equal to z1 plus lambda c. These are parametric equation of the line. Eliminating the parameter lambda from 2, we get x minus x1 a, y minus y1 b, y1 divided by b, z minus z1 divided by c. Third, this is Cartesian equation of line. If L, M and R direction cosines of the line, the equation of line is x minus x1 divided by L, y minus y1 divided by m, z minus z1 divided by n. Example 6. Find the vector and the Cartesian equation of the line through the point 5, 2, minus 4, and which is parallel to the vector 3 I cap plus 2 z cap minus 8 k cap. Solution: we have a vector is equal to 5 I cap plus 2 z cap 2 z cap minus 4 k cap, and b vector is equal to 3 I cap plus 2 z cap minus 8 k cap. Therefore, the equation of the line is r vector is equal to 5 I cap plus 2 z j cap minus 4 k cap plus lambda 3 I cap plus 2 j cap minus 8 k cap. Now r vector is the position vector of any point p x, y, z on the line. Therefore, x I cap plus y z cap plus z k cap is equal to 5 I cap plus 2 z cap minus 4 k cap plus lambda 3 I cap plus 2 j cap minus 8 k cap is equal to 5 plus 3 lambda I cap plus 2 plus 2 lambda z cap plus minus 4 minus 8 lambda k cap. Eliminating lambda, we get x minus 5, 3 y minus 2 divided by 2, z plus 4 divided by minus 8. This is the equation of line in Cartesian form. 11.4 Angle between two lines. Let I1 and L2 be two lines passing through the origin and with direction ratios A1, B1, C1 and A2, B2, C2 respectively. Let P be a point on L1 and Q be a point on L2. Look at the figure. Consider the directed lines OP and OQ as given in figure 11.4. Consider the let theta be the acute angle between OP and OQ. Now recall the directed line segments OP and OQ are vectors with components A1, B1, C1 and A2, B2, C2 respectively. Therefore, the angle theta between them is given by cos theta in modulus A1 A2 plus B1 B2 plus C1 C2 under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. The angle between the lines in terms of sin theta is given by under root 1 minus cos square theta is equal to 1 minus A1 into A2 plus B1 into B2 plus C1 into C2 whole square and divided by A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square is equal to under root A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square minus A1 into A2 plus B1 into B2 plus C1 into C2 whole square under root A1 square plus B1 square plus C1 square and into under root A2 square plus B2 square plus C2 square is equal to A1 B2 minus A2 B2 A1 into B2 minus A2 into B1 whole square plus B1 into C2 minus B2 into C1 whole square plus C1 into A2 minus C2 into A1 whole square under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. Equation 2. Note, in the case the lines L1 and L2 do not pass through the origin, we may take lines L1 and L2 which are parallel to L1 and L2 respectively and pass through the origin. If instead of the direction ratios for the lines L1 and L2 direction cosines, namely L1 M1 N1 for L1 and L2 M2 N2 for L2 are given, then equation 1 and 2 takes the following form: cos theta in modulus L1 into L2 plus M1 into M2 plus N1 into N2 as L square plus M1 square plus N1 square is equal to 1 is equal to L2 square plus M2 square plus N2 square is equal to 1. Equation third. And sin theta is equal to L1 into M2 minus L2 into M1 whole square minus M1 into N2 minus M2 minus N1 whole square plus N1 into L2 minus N2 minus L1 whole square. Equation 4. Two lines where direction ratios A1 B1 C1 and 2 B2 C2 are first perpendicular, that is if theta is equal to 90 degree by 1, A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0. Parallel, if theta is equal to 0 by 2, A1 divided by A2 is equal to B1 by B2 is equal to C1 upon C2. Now we find that angles between two lines when their equations are given. If theta is acute, then angle between the lines r vector is equal to A1 plus lambda B1 is equal to, and r is vector is equal to A2 plus nu B vector. Then cos theta is equal to, in modulus, B1 vector into B2 vector under root B1 modulus of B1 vector and B1 B2 modulus of B2 vector. In Cartesian form, if theta is the angle between the lines, x minus x1 A1 is equal to y minus y1 divided by B1 and z minus z1 divided by C1. Equation 1. And x minus x2 divided by A2 and equal to y minus y2 divided by B2. Z is equal to z minus z2 upon C2, where A1 B1 C1 and A2 B2 C2 are the direction ratios of the lines 1 and 2 respectively. Then cos theta is equal to A1 into A2 plus B1 into B2 plus C1 into C2 under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. Example 7. Find the angle between the pair of lines given by r vector is equal to 3i cap plus 2j cap minus 4k cap plus lambda I cap plus 2z cap plus 2k cap, and r cap is equal to, r vector is equal to pi cap minus 2j cap plus nu 3i cap plus 2j cap plus 6k cap. Solution. Here B1 vector is equal to I cap plus 2j cap plus 2k cap, and B2 is equal to B2 is equal to 3i cap plus 2j cap plus 6k cap. The angle theta between the two lines is given by in modulus B1 vector into B2 vector and modulus of B1 into modulus of B2 is equal to I cap plus 2j cap plus 2k cap into 3i cap plus 2j cap plus 6k cap under root 1 plus 4 plus 4 into under root 9 plus 4 plus 36, which is equal to 3 plus 4 plus 12 divided by 3 into 7, which is equal to 9 into 21. Hence theta is equal to cos inverse 19 by 21. Example 10. Find the angle between the pair of lines x plus 3 divided by 3 is equal to y minus 1 divided by 5 is equal to z plus 3 divided by 4, and x plus 1 divided by 1 is equal to y minus 4 divided by 1 is equal to z minus 5 divided by 2. The solution. The direction ratios of the first line are 3 5 3 5 4, and the direction ratios of the second line are 1 2. If theta is angle between them, then cos theta is equal to 3 into 1 plus 5 into 1 plus 4 into 2 under root divided by under root 3 square plus 5 square plus 4 square into under root 1 square plus 1 square plus 2 square, which is equal to 16 into 50 16 into 16 divided by under root 15 to 6 is equal to 16 divided by 5 root 2 into 6 root 2, which is equal to 8 root 3 under root 15. Hence the required angle is cos inverse 8 root 3 15. 11.5 the shortest distance between two lines. If two lines in space intersect at point, then the shortest distance between them is 0. Also, if two lines in space are parallel, then the shortest distance between them will be perpendicular distance, that is length of perpendicular drawn from a point on the line onto to the other line. Further in space, there are lines which are neither intersecting nor parallel. In fact, such pair of lines are coplanar and are skew lines. For example, let us consider a room of size 1, 3, 2 units along x, y, and z axis respectively. Figure 11.5. The line G that goes diagonally across the ceiling and the line DB passes through one corner of the ceiling directly above A and goes diagonally down the wall. These lines are skew because they are not parallel and also never meet. By the shortest distance between two lines, we mean the join of a point in one line with one point on the other line, so that the length of the line segment so obtained is the smallest. For skew lines, the line of the shortest distance will be perpendicular to both the lines. 11.5.1 distance between two skew lines. 11.5.1 distance between two skew lines. We now determine the shortest distance between the two skew lines in the following way. Let L1 and I2 be two skew lines with equation figure 11.6. R is equal to A1 vector plus lambda B1. R vector is equal to A2 vector plus nu B2. Equation 2. Take any point S on L1 with position vector A1 and T on L2 with position vector A2. Then magnitude of the shortest distance vector will be equal to the projection of ST along the direction of the line. The direction of the line shortest distance. C 10.6.2. If vector PQ is the shortest distance vector between L1 and L2, then it being perpendicular to both B1 vector and B2 vector, the unit vector n cap along PQ would therefore be n cap B1 vector into B2 vector in modulus B1 vector into B2 vector. Then PQ is equal to D n cap, where D is the magnitude of the shortest distance vector and theta be the angle between ST vector and PQ vector. Then PQ is equal to ST modulus cos theta, but cos theta is equal to in modulus PQ into ST vector divided by modulus of PQ vector into ST vector, equal to in modulus D into n cap into A2 minus A1, D is equal to ST. Since ST is equal to A2 minus A1 is equal to B1 vector into B2 vector into A2 vector minus A1 vector. ST is equal to B1 vector into B2 vector. Hence, the required shortest distance is D is equal to PQ is equal to ST cos theta. D is equal to B1 vector into B2 vector into A2 minus A1 vector divided by B1 into B2 modulus whole, and D is equal to whole modulus. Cartesian form, the shortest distance between the lines L1 is equal to L1 x minus x1 divided by A1 y1 y minus y1 divided by b1 z minus z1 divided by c1, and L2 x minus x2 divided by a2 y minus y2 divided by b2 z minus z2 divided by c2 is in whole modulus, numerator modulus x2 minus x1, y2 minus y1, z2 minus z1, then a1 b1 c1, and then a2 b2 c2 under root divided by under root b1 into c2 minus b2 into c2 whole square plus c1 into a2 minus c2 into a1 whole square plus a1 into b1 minus a2 into b2 whole square. 11.5.2 Distance between parallel lines. If two lines L1 and L2 are parallel, then they are coplanar. Let the lines given by r vector is equal to a1 cap plus lambda b cap, r is equal to a2 cap plus nu b cap, where a1 is the position vector of a point S on L1 and a2 is the position vector of a point T on L2. Figure 11.7. As L1 and L2 are coplanar, if the foot of the perpendicular from T on the line L1 is P, then the distance between the lines L1 and L2 is equal to modulus Tp. Let theta be the angle between the vectors st cap and b cap, then b into st and equal to under root b vector into st vector sin theta n, where n cap is the unit vector perpendicular to the plane of the lines L1 and L2. But st vector is equal to a2 vector minus a1 vector. Therefore, from third we get b1 cap into a2 minus a1 is equal to b vector cap pt n vector. Since pt is equal to st sin theta, b vector into a2 minus a1 vector is equal to b modulus cap pt minus 1, as n vector is equal to 1. Hence the distance between the given parallel line is pt cap is equal to b into a2 minus a1 whole modulus divided by b vector. Find the example 9. Find the shortest distance between the lines L1 and L2 whose vector equations are r cap is equal to I plus j plus lambda 2i vector minus j vector plus k vector, equation 1, and r cap is equal to 2i cap plus 2 plus j cap minus k cap plus nu 3i cap plus 5 minus 5j cap plus 2k cap. Solution. Comparing 1 and 2 with r cap is equal to a1 cap plus lambda b1 and r cap is equal to a2 cap plus nu b2 respectively, we get a1 is equal to I plus j, b1 is equal to 2i minus j plus k, a2 is equal to 2i minus j minus k, and b2 is equal to 3i cap minus 5j cap plus 2k cap. Therefore a2 minus a1 is equal to I minus k, b1 into b2 2i cap minus j cap plus k cap into 3i cap minus 5j cap plus 2k cap is equal to I cap plus j cap plus k cap 2 minus 1 1 3 minus 5 2 is equal to 3i cap minus j cap plus minus 7k cap. So in modulus b1 vector into b2 vector is equal to 9 plus 1 plus 49 is equal to under root 59. Hence the shortest distance between the given lines is given by d is equal to modulus b1 into b2 vector plus into a2 minus a1 vector divided by modulus b1 into b2 vector is equal to 13 minus 0 plus 71 under root 59, which is equal to 10 divided by under root 59. Example 10. Find the distance between the lines L1 and L2 given by r cap and I vector plus 2j cap minus 4k cap plus lambda 2i cap plus 3j cap plus 6k cap. R vector is equal to 3i cap plus 3j cap minus 5k cap plus nu 2i cap plus 3j cap plus 6k cap. The two lines are parallel. Why? we have a1 vector is equal to I cap plus 2j cap minus 4k cap, and 3I cap plus 3j cap minus 5k cap, and b vector is equal to 2I cap plus 3j cap plus 6k cap. Therefore, the distance between the lines is given by d is equal to in modulus b1 into a2 minus a1 cap divided by divided by modulus b vector, which is equal to ijk 2 2 3 6 2 1 minus 1 divided by under root 4 plus 9 plus 6 9 plus 36, which is equal to 1 minus 9I cap plus 14j cap minus in modulus 9I cap minus in modulus minus 9I cap plus 14j cap minus 4k cap divided by under root 49, which is equal to under root 293 divided by under root 49, which is equal to under root 293 divided by 7. So here is 11.2, which we will discuss in next video. So miscellaneous exercise is also here, but let us see the summary. Direction cosines of a line are the cosines of the angles made by the line with the positive direction of the coordinate axis. If L, M, N are the direction cosines of a line, then L square plus M square plus N square is equal to 1. Direction cosines of a line joining the 2 points P, x1, y1, z1 and Q, x2, y2, z2 are x2 minus x1 divided by pq, y2 minus y1 divided by pq, z2 minus z1 divided by pq, where pq is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Direction ratios of a line are the numbers which are proportional to the direction cosines of a line. If L, M, N are the direction cosines and A, B, C are the direction ratios of a line, then L is equal to A under root A square plus B square plus C square, M is equal to B under root A square plus B square plus C square, N is equal to C under root A square plus B square plus C square. Skew lines are the lines in space which are neither parallel nor intersecting. They lie in different planes. Angle between skew lines is the angle between two intersecting lines drawn from any point, preferably through the origin, parallel to each of the skew lines. If L1, M1, N1 and L2, M2, N2 are the direction cosines of the two lines and theta is the acute angle between two lines, then cos theta is equal to in modulus L1 into L2 plus M1 into M2 plus N1 into N2. If A1, B1, C1 and A2, B2, C2 are the direction ratios of the two lines and theta is the acute angle between the two lines, then cos theta is equal to in modulus A1 into A2 plus B1 into B2 plus C1 into C2 divided by under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. Vector equation of a line that passes through the given point whose position vector is A cap A and parallel to a given vector B is R vector is equal to A vector plus lambda B vector. Equation of a line through a point x1, y1, z1 and having direction cosines L, M, L, M, N is x minus x1 L is equal to y minus y1 divided by M is equal to z minus z1 divided by N. The vector equation of a line which passes through 2 points whose position vectors are A cap A vector and B vector is R vector is equal to A cap plus lambda P minus B vector minus A cap dot. If theta is the acute angle between R cap R vector is equal to A1 cap plus lambda B1 cap and R2 is equal to A2 cap plus lambda B2 cap, then cos theta is equal to A in modulus B1 vector into B2 vector in modulus B1 vector plus into B2 vector. If x minus x1 divided by L1 is equal to y minus y1 divided by M1 is equal to z minus z1 divided by N1 and x minus x2 divided by L2 equal to y minus y2 divided by m2 and z minus z2 divided by n2 are the equation of two lines, then the acute angle between the two lines is given by cos theta is equal to 11 into L2 plus M1 into M2 plus N1 into N2. Shortest distance between two skew lines is the line segment perpendicular to both lines. Shortest distance between R vector is equal to A1 vector plus lambda B1 and R2 and R vector is equal to A2 vector plus nu B2 is modulus b1 vector into b2 vector into a2 minus a1 vector divided by in modulus b1 into b2. Shortest distance between the lines x minus x1 divided by a1 is equal to y minus y1 divided by b1, z minus z1 divided by c1 and x minus x2 divided by a2, y minus y2 divided by b2 and z minus z2 divided by C2 is under root in modulus x2 minus x1, y2 minus y1, z2 minus z1, a1 comma a1 b1 c1, a2 b2 c2 divided by under root b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a2 whole square plus a1 b2 minus a2 b1 whole square. Distance between parallel lines are vector is equal to a1 vector plus lambda b vector and r vector is equal to a2 nu b vector is in modulus
b vector into a2 vector minus a1 vector divided by vector b modulus in modulus. So this was the chapter guys. I hope आपको ये हेल्पफुल रहा होगा. अगर रहा होगा तो ज़रूर लाइक कर दें यार, और फ्यूचर में मैं अच्छी वीडियोस लाने की कोशिश करूँगा, तो सब्सक्राइब कर देना. और ऑल द बेस्ट फॉर योर एग्जामिनेशंस एंड हैव अ गुड लाइफ. सी यू सून इन द नेक्स्ट वीडियो.